Welcome. In this video, we're going to be doing something that adds to the casual game mechanics. So we're just going to quickly build a little fish controller that's going to be very much like Flappy Bird. Simple camera that follows, and then we're going to be spending the rest of the video creating a kind of a level generator that is just going to generate objects at an interval over towards the right. You could change this to go down, up, whatever direction you want. Let me show you the setup for the scene. We just have a normal fish with a rigid body and a capsule collider, so I'm making this in 3D, even though I'm using a sprite. I have a camera that's got a root object that is in the exact location of the fish, so that all I can do is just move the camera wherever I'd like it, and the root will stay rooted to the play itself. I have a manager game object, which we're going to add code to, and I have a folder called pools. So we have an object pool and a current pool. So the object pool is a group of deactivated objects. I just put in a few in here. Let's turn them on just to kind of show you that there's some variety in here. So we have a red one. We should have a darker green one, I think this is. There we go. We have another one here. So we have a few different variety as far as the objects available. So we're not instantiating anything in this object pooling exercise. It's a very basic introduction. So we're just actually starting with in this case, with 14 objects that already exist in the world. So the object pool is the objects that aren't being used, and then we're going to move the ones we are using to the current pool object. Okay, so let's start by getting this moving. Let's apologies. So let's add a simple flow machine to this object. And we're just going to create the two variables we need. We need let's call this a forward speed. Let's call it that. Oh, sorry, let's try that again without caps lock on. Forward speed. And it's going to be a float, and I'm setting the forward speed to something like 0.05 from what I did when I did the C# equivalent. And then this one is going to be the upward force, so the amount of jump, if you will, that this character will be able to do. It's also a float, and it's going to be, I think 5 units is enough. Okay, so those are my variables. We're going to go into create a script that we can use these variables in. I'm going to call this fish controller. Go. Open up the graph, put the graph where it belongs on screen, and we're going to do two things here. So we're going to delete this, and we're going to put everything in the update. So in the update, we're going to first add movement, the forward movement, the constant forward movement. So we're going to use a transform.translate. You'll probably notice I very seldomly use the same thing twice, because I like showing that there are new different ways you can do the same thing. Why is transform.translate not showing up? Let's right click and add a transform.translate. There we go. Welcome transform.translate. Oh wait, I don't want the x, y, and z to be separate, so we're going to grab a transform.translate and just get a combined value like that. So we're going to be moving the object, and then afterwards we're going to listen for if my left mouse button down, this can be any button you want to make it jump. So what are we moving this object in? We're going to get the rights from left to right is right, so we're going to type in v3.right, and we're going to get the right, and we're going to multiply that by our speed value. And this is where you can multiply it by time.delta time. I'm not going to do it for this exercise because we're just translating the object. It should be fine. But again, it's always safer to put in time.delta time if I were you. So I'm going to plug in the forward movement, and now we have the character moving forward. So let's just move this across, put a comment group around this, and add side to side movement for the fish. That's what we're doing here. So we're just adding side-to-side movement, allowing the fish to move in from left to right at a constant rate. And then after this, we're going to do a input.get mouse button down. So is the mouse button down? 0 is the left mouse button, which is the one I want to use. I want to put a branch to block off the false. This will only happen if it is true. So if I have hit the left mouse button, I want to move the little fish up in the world. But in order, because we're using force for this, I want to start by apologies, typing in rigid body dot velocity. Now I want to set the velocity to 0, because what happens is whenever you're working with rigid bodies or force or any of that kind of thing, it will still take the force that you had. So as it's falling down and you add force directly without zeroing out the velocity, you're going to get a small little hop, because it's trying to it's adding to the current velocity that you have, which is going down, and then you're telling it, by the way, you need to go up. So what we're doing here is, as it falls down and I hit the left mouse button, it's going to lose all velocity because I'm zeroing it out here, and then add new velocity in the opposite direction. Okay, so once we zero out the velocity, it's going to happen for 1 frame over the click, and then we're going to say rigid body dot add force. We're going to add force. It's going to be an impulse. I want it to be kind of an instantaneous little punchy kind of movement. And what are we going to add force? If we're moving right, we're going to want to add force in the up. So we're going to go and say vector3 dot up. We're going to multiply that value again, plug the output into the force over there. And what are we multiplying this value by? This upward force. And that's pretty much it. So I'm going to put a comment group around this and say left mouse click will add force in the y axis. There we go. So that's what that does. So let's test this out to see how that looks and how that works. You should watch it here. The character is going to go forward. And when I hit the button, it goes up. And that's it. So now that we got a little kind of Flappy Bird kind of vibe, I'm just going to, again, this isn't about the controller itself. This is more about the actual system that we're going to be creating. So I'm just going to grab the camera, quickly add a flow machine to the camera. And in here, we're going to add a player ref inside of this variable tab section here. I'm going to choose a transform because I just want to know where the player, get the transform of the player, and assign the fish. And then we can create a new script here and call this fish camera controller. Something like that should be fine. Whoops, I put it. Anyway, spelling is what it is now. And over here, we're going to delete this and we just need the update. So the update, we're going to say transform.position. We're going to set the position, and we do not worry about the y or the z. We just want it to follow in the x. So we're going to split this out into a new vector 3, x, y, z. We're going to leave the y, we're going to leave the z. All we care about now is finding drag the variable of the player ref in here, and we're going to say grab the transform.position, and all we care about in this case is the vector3.x position, and we're going to plug that directly into the x. And that's it for the camera. So we're going to put a comment around this and say camera follows player in the x direction. Let's call it that. And how do I know what the x is? I just select my character, go to the move tool, and just look at, that's the x. This is the direction I want the camera to follow. So I'm telling it to be 0 in the y and 0 in the x, which it is already inside of the transform. So let's just see what that looks like. You should see the camera follow the character in the scene view. There we go. And it's following the little fish as we move. So now that we have the base controller and the base camera, we can go in and add a manager. So we're going to go into our manager script. Oh, sorry, the manager game object. And we're going to start by adding a manager code that is required. So let's select this, add a flow machine, create a new script. Let's put in the scripts folder and let's call this level generator, I guess. Level generator, that should be fine. And I want to maximize this. Now, we need three different functions. We have the start, the update, and then we need a custom one that we're going to create. So we're going to go and add a unit and type in custom event. And this one we're going to call, let's call it like generate platform or something. Generate platform. And now we have the three functions we need. So we're going to start by adding all the variables that we need starting from the graph. Think of graph variables as private variables. They're accessible by the graph, but they're hidden inside of the editor. So we're going to click here. We're going to say, well, first we need to keep track of how many platforms we have. So we're going to add a platform count, which is going to be an integer. We need let's call this last platform position. So last platform position, and that's going to be a vector 3. So this is the last position, the platform where it was at the last position we had. So by default, it's going to be 0, 0, 0. And then the last one is going to be a game object, which is going to be called next platform. So what is the next platform that we're going to be generating? Change it to game object. And those are the three hidden variables: platform count, last platform position, and the platform itself, the object that we're actually talking to. We're now going to move over to our object variables and create all the serialized field variables or the visible variables. Okay, sorry, I was just moving my to my reference. And now we need to have a reference to the current object pool, like which one, the object pool that's holding all the deactivated objects. And this is going to be a transform. We have to search for it. The next one is going to be the current pool. We should probably say deactivated pool and activated pool or whatever, but current pool. This one's also going to be a transform. And we're just going to assign this from the scene. So I'm going to click on the little circle to the right of it, go into my scene and look for my object pool, and do the same thing for my current pool. So that there, because I don't know if anyone who's worked with Bolt long enough realizes if you don't actually assign something to a variable in Bolt and you go out of Bolt and come back in to this flow graph, it will be set as null. Like you'll see, it's gonna happen with this one over here. So now that we have the object pool and the current object pool, we need to add the next variable, which is going to be the height offset. This is the amount that we're going to have a random offset value for these little seaweeds, so that the little gap that you're swimming through isn't always in the middle of the screen. It will go up or go down. So this is going to be a float, and let's make this like 2.5. It's going to be too much, but I'm kind of just messing around with that value. This is based on my scene. That value could change based on yours. Next one is going to be a platform distance. So the distance between each of the platforms that get instantiated. Now this one's going to be very important depending on your level. If your levels are all, let's say, 2 units across, then this value here will have to be taking into account the size of the level that you're instantiating or platform. I'm just instantiating little seaweed, so you can't really tell. But if you're instantiating an entire piece of a level, you're going to want to make sure that this platform distance is taking into account the actual size of the platform, so that when they get offset, they're offset like perfectly side by side to each other. So I'm going to put this as, let's make it 5. Okay, so we have the platform distance, and then the next one is a reference to the player. So we're just going to call this player ref, like we did in the camera. This one needs to be a transform. And we're just going to click on here and choose the fish bolt as the reference for that variable. And then all that's left now is to create 2 more variables. The one is how far away from the platform that we're moving to do we need to be before we spawn a new one. So we're going to call this a spawn distance. Make this a float. And because my fish is in a negative value, I'm going to change the spawn distance to -5. What I mean by that is, because if I select my fish, he's currently a negative value, so he'll always be a negative value from the target that he's moving to. So that's why I'm putting a negative value into my apologies, in my, let me select my manager again. in my offset. The spawn distance could be a positive value on yours depending. And then the last one is going to be, we're going to call this a pool limit. So the amount of active objects that can be in the scene. That's going to be an integer, and I'm going to say I only want to have 5 active platforms at any given point. If there's more than that, set that, put it back into the object pool. Okay, so let's start. We're going to go into the start, then the update, then into the custom function where most of the work happens. So at the start, we're going to first go to our graph variables and hold down Alt and drag in our platform count. Go back to our object and drag in the object pool. What I want to do is at the start, we're creating this variable because it's easier than always getting the child count of the object pool. It's just neater to have one variable. So we're saying get the child count of this object pool and set that platform value count to be the total of objects in this object pool. And then just for safety's sake, we're going to go back to the graph, hold down Alt and drag in the last position. And we're going to set that to a vector3.literal. We're going to set that to 0, 0, 0 when the game starts. You might have some save variables and you might have some weird stuff. So I'm just resetting all of this at the start of the game just to be safe. After this, all we're going to do is call this function down here. So I'm going to copy that. I'm going to drag off this and type in trigger custom event. I'm going to paste that name that I just got from down here up to here. Okay, so that's all we're doing at the start. So at the start, we're going to put a comment group around this, and we're going to say resetting the last position and updating the platform count at start. That's all we're really doing. We're just resetting the last position and updating the platform count at the start. Oh, sorry about that, guys. My dog just went crazy. Okay, so now in the update, we're going to do something. We're going to say so we're going to do a branch here just to do an if statement. So we're going to go branch. So we're going to ask ourselves, when are we going to generate platforms? We clearly are generating one when we start. But when do we generate new platforms again? So this is going to be based on where the player is. That's why we got a reference in the object variables to the player. So we're going to grab out the player, and we're going to find the player's x position. So we're going to go transform.position get. We're going to drag in and type in v3.x because I only care about the x position. Now what I'm doing here, you could use a get distance node. I think you need to do a, hold on, I think it would be a vector3.get distance. This is not a vector3.get distance. Oh, maybe it's a transform.get distance. But anyway, you can do a just distance and see what options we have here. Yeah, we can just use this distance node instead of doing what I'm about to do. So you could do this. Let me just leave this off to the side and show you what we're doing. We're grabbing the player position, and then we're going to go and grab the last platform position. We're going to duplicate this node and just plug that in there, because we're getting the distance between the player's current position and the last platform that was generated position, and we're going to subtract those values. There we go. And then once we have this, doing this is exactly the same way as just plugging that. So we could plug in this and plug in that, and we would get the same result. That node just does all of this kind of logic inside of that node. But I just want to kind of show you how you get the distance of something between two objects. So we're grabbing the current object, we're getting the platform's current position, and we're getting a float value. This is going to be a single value, and then this value we're going to compare. We're going to say, are you greater or equal to, and then we're just going to plug that in there. And what is this equal to? And we created a variable in the object called spawn distance. So if the distance between these two objects is greater than -5, or equal to -5, then we're going to spawn a new platform. That's all we're doing here. We're saying find the distance between these two objects, check to see if the distance is greater than -5. If it is, all we're going to do after here is just duplicate this custom trigger and plug that into true. Okay, so that's it for the update. So every frame we're going to check to see where the player is in relation to the platform, and then we're going to do something. We're either going to instantiate or we're going to do nothing because we're not there yet. That's all that we're doing at this point of the code. So let's call this let's call it enable new platform when the player is in range of the spawn distance. There we go. I think something like that makes sense. Okay, now that's all that we've done, all the kind of prep work. All we need to do now is basically just call this, actually do the instantiation, do the spawning, if you will. So that happens inside of the custom event. We're going to drag off this, and we're going to do this code one more time. This part here, we're going to duplicate these 3 nodes, because at the start we do that once, but we need to update the platform count every single frame. Every single time we call this function, we look at the object pool and we say how many children are left in the list. Now, the reason we're using a child count is because if we look at our object pool, it has 14 children. So we're getting the count of those 14 children so that we can use it at a later stage. So every time we remove a child from this list, we have to update the platform count because now it's 1 less. So that's what we're doing at this point of the code. We're just updating the child count on the updated list size, or child size. Next thing we need to do is update our next platform. Hold down Alt and drag that in. What is this next platform? We are going to randomly select a platform from the object pool and set it here. So how do we do that? We're going to drag off the object pool and type in get child. Now you'll see there's an index value, so we can plug that child into this variable here. So right now it'll select the first child in the list, but we want to kind of make it a little more random. So we're going to drag off there and type in random.range. We're going to choose the bottom one because it's an integer. It doesn't make a difference. It will rectify it for you if you choose the so-called wrong one. It should be fine. So lists can never be smaller than 0, or objects can can't have negative objects. It can only have 0 objects. So we're leaving the minimum as 0, and then the count itself, we're going to use the platform count. We're going to drag off the platform count, and we're going to plug that into the B. I'm going to leave this as it is to show you that we need to come back and rectify this, but this is the minimum and the maximum children in the list. Pick one and assign it to the new platform. Okay, once we've created this object, we want to set its parent to be the new one, which is the current pool. So we're going to drag off this and type in transform.setParent. Select that one, plug that in. And what is the parent? Pretty simple. Grab the current pool and set that as the new parent. After we've set the parent, we want to update its position. We don't want this, like if we look at the current situation with this object, I'm going to turn one of these on. So let's say that's the one, it's currently over there. So we don't want them all to instantiate at the same place because we want them to kind of offset every time it gets instantiated. So we need to grab this object, then set a positional value for that. And that's what we're going to do here. So once we're done with this, we're going to just, to keep things nice and neat, I'm going to grab the next platform and just drag it over here. And we're going to drag off this, and we're going to set the position. So we're going to go and say transform.position set. We're just going to give ourselves a little bit of room because I have 2 offsets that I need to do. So I'm going to break this into a vector3.xyz. And we need to kind of do the following. We need to say, okay, cool. Where are we in the x? So the x is going to grab the last position. And we only care about the x, so we're going to type in v3.x. So where was the last platform? Get that position. and then we're going to add to that. We're going to add the platform distance, which is in our object variables. We're going to add the 5 to the current platform in the X position, which means it's going to go 5. Let's say the platform's here. It's going to add 5 and put it over there. And it's going to do that every time we update the platform. We are going to get a new platform position, and then we're going to add 5 every time we instantiate or we move an object. So that's the X. The Y is going to be using a random.range again. So random.range. We want it to be a float, and the minimum and maximum value are, in this case, are going to both be the height offset. So I'm going to drag the height offset, and that's going to be the maximum. And Bolt doesn't have some really cool kind of coding where I can just turn this into a negative value. So I need to go and do like one extra node. So I'm going to drag off here and say multiply, and plug that into the minimum. And what am I multiplying it by? A integer, and it's going to be, it's actually a float. What am I doing? Just make it a float so we don't get any issues, by -1. So what that does is, if this value is 5, I'm going to multiply by -1. It's going to give us a negative value. So that is for our random offset, and that's pretty much for our position. Okay, so once we've moved the object is currently deactivated. So we need to activate that object. We need to set that object to be true so we can see it in the game. So again, I'm just duplicating this up for cleanliness. And we're going to say, by the way, you need to be set active. You're looking for game object.set active, and that needs to be true. And then all we need to do, one more thing for the next round, we always got to think a step ahead. I'm going to grab my next platform, hold down Alt and drag that in, and set this to be the next platform. Because the initial platform, remember, is not next platform, what am I saying? Sorry, next, the last position is what I need to do. What am I doing? So the initial position 0, 0, 0. So I need to say, please grab the transform.position of this. Let's try that again, transform.position, and plug that in as the new position. And then, because when we add 5, we don't want to be adding 5 to 0 all the time, because then they're all going to always end up in the same place. Okay, so this is all the code we need. Let me just move this outside. This part of the code here is to, let's say, randomly select a child in the object pool and move it to the current pool and activate it. That's all we're doing there. So we're grabbing a selected child in the object pool and moving it to the current active pool. So we'll see that right now. Watch this section. I'm just going to move this down. Watch how they're going to move from this object pool, and they're going to move into the current pool, and then at one point we are going to run out of objects to instantiate. You'll see it if I just pause the game really quickly as we start. Zoom out, so you can see that we're going to run out of objects to spawn. So once the player gets to that last position, which is there, you saw it's instantiated and it's building them all up. I think my forward movement needs to be a little bit faster. It's a little bit slow. But notice how the object pool is getting less and less. It's now down to about 6 items. We're going to get to a point where we're going to run out of objects to instantiate in 3, 2, 1, and then it's going to hit 0, and then we're going to have no more objects to instantiate. Notice how we no longer have, I'm going to keep flapping past it. Notice how we no longer have any more objects. Now, in a more advanced pooling system, you'd want to probably say, once we've run out of objects in the pool, please instantiate a new one to add to it. But this game, you really only need a certain amount of active pool objects at any given point. So we don't need to be instantiating. Use the ones we have and work with the ones we do have. So if I open up the current object pool, notice how we have all of these objects. So we're going to go in here, we're going to say, if the current pool has got more than a certain amount, please move them back to the object pool. And we're just going to do that. We're going to keep moving them back one at a time, and then turning them off again. So, and then if we start the game now, notice how I had enough to bring up to the front again, and then we run out all over again. So we need to put in some fail safes. Yeah, I'm getting an error here. The reason we're getting an error is that we're getting an index out of bounds. So what I need to do here is, I said we'd have to come back and fix this. In code, it doesn't seem to be the issue, but in Bolt, we need to actually subtract 1 from this, because remember, this is a lot like a list. A list starts at 0 and counts all the way to 13 in this case. This one, when we get the count, it's counting at 1 all the way to 14, so we're going to get 1 value out of range. So we just need to drag this out, subtract 1 from that total, so we don't get this index out of range. Whenever you see an index out of range, that means it's trying to find an item in a list that doesn't exist. So we're going to subtract, I think it can be just a straight up int, because there's no float values inside of a list. And this should get rid of that error that we have. We will no longer have this index out of range issue. Okay, so right at the end here, we need to do a small if statement. So we're going to drag off and say branch. And we're going to check for something, and it's going to be quite simple. We're going to check to see if our current pool, we're going to get the child count. And we're going to compare that to see if that is greater or equal to. I always do greater or equal to in most of my cases, because it's very seldom. This is technically an integer, so we should get a whole number anyway, but I'm always rather safe than sorry. So if it's greater or equal to what? I could put in a hard-coded value in here, but I did create a pool limit variable here. So let's use that. So once we have more than 5 objects, or equal to 5 objects, we are going to say, please do the following. Grab the current pool. So let's duplicate that. Get the child. So we're going to say get child. And in this case, index 0. Index 0 is the first child that got added to the group, which means it's the oldest child, which means the chances are it's outside of the frame already. So we're getting the first child. And we're saying, please deactivate this. So type in set active. And leave it as false, because we want to turn it off. And then all we have to do now is, now that we've turned it off, we needed to put it back into the object pool. So after that's done, we're going to go and say, please set the parent of this object. And we're setting the parent back to the object pool. So go back to being in idle and waiting to be called for your time in the sun, if you will. So we're going to do that. And we're just going to put a comment around all of this. Just giving myself a little bit of room to work with here. And this one's going to be the current pool has a limit, and when it is met, disable the first child and move it back to the object pool. That's all we're doing here. And we can test this out, and then we're pretty much done. So that's in the entire very basic introductory level to object pooling. You'll see that I'm going to, again, pause the game at the start, just to open up the object pool area, because now that there's something in there, watch how we'll never get past 5 objects in this current pool. And you'll see it in the scene view as well, if you would just keep an eye on the scene view. Notice how we're almost at the limit of 5. Notice how, there we go, we don't ever go past that point. So we always keep the same amount. Seems to be a good amount to have right now. So every time it happens, we just keep adding new objects and keep moving them between the 2 pools. So we never ever go past a certain amount of objects that are active at any given point. And that's it. That is how we do simple introductory to object pooling along with an infinite level. So this could be anything. It doesn't have to be seaweed. It could be a level. It could be multiple types of levels, little dungeon areas that you build up, and you go as an artist, go and create authored versions of it, where some have pickups, some don't, some have enemies, some don't, and you can just go and create something like this. And that's it. So thank you so much for watching. Hopefully this has been helpful. And till I see you next time, be safe and take care of yourself. Cheers, guys.